Braunschweig, exactly. So I'm a research associate at the Institute of Building Materials, Concrete Construction and Fire Safety of the Technische University in Braunschweig. And currently I'm doing some research work on the material behavior of concrete in the so-called cooling phase, considering natural fire models. Today I want to present some empirical data that I have collected in nursery schools during my master thesis and talk about the challenges when implementing this data into evacuation models. So, ensuring life safety is a priority aspect of structural, technical, and organizational fire protection measures. The problem for nursery schools in Germany is that there are no uniform rules and guidelines for fire protection, which actually leads to a different level of safety between the individual buildings. Also, there are no statutory evacuation exercises which could increase the safety in the building. So currently, fire protection in nursery schools is mainly ensured with structural and increasingly with technical measures. Considering children, some of these measures might be ineffective and in the worst case even have a negative impact on the children's safety. So for example, some alarm systems can induce anxiety in the children. So when choosing the fire protection measures, it has to be questioned if they are also suitable for children. And this actually implies the question if through organizational measures, a missing structural or technical measure can be compensated with. So even some structural or technical measures are questionable considering children. So far, performance-based life safety concepts with regard to the organizational fire protection measures and evacuation simulation models are regarded as an inadequate option. So what were the main objectives? Well, the examination of the evacuation organization and behavioral patterns in nursery schools, the collection of empirical data from evacuation exercises in different nursery schools, and here the main focus was on the pre-movement time and its measurement. And in the next step, based on the collected data, a model was developed with FDS-EVAC, which tries to depict the special situation in nursery schools. In the next step, the exercise and simulation results were compared to each other, and the final aim was to formulate an optimization potential regarding fire safety in nursery schools in Germany. So, as you know, in order to ensure a performance-based life safety concept, in case of fire, it has to be proven that the available safe egress time is greater than the required safe egress time. And our set of the occupants consists of the detection time, the alerting time, the individual pre-movement time, and the individual movement time. And in some cases, the alerting time can also be individual. Well, this is in the case when the building, for example, does not have an alarm system and the occupants have to be alarmed at different times, for example, by other occupants. So, however, these individual parameters in turn lead to a scattering of the individual required safe egress time, and this does not apply to the occupants in nursery schools. And this is because of the evacuation organization. So the evacuation does not begin until all children have assembled. So if a child does not respond to the educator's instructions because of anxiety or it is curious and doesn't join the group, it will increase the group-related pre-movement time and therefore delay the evacuation of the group. So evacuation exercises serve building users to test dangerous or emergency situations, and only through the exercises wrong behavior can be avoided in the future and an optimized evacuation be conducted. For our research, we selected 4 different types of nursery schools, and these differences result from inequalities between the structural, technical, and organizational fire protection measures in the nursery school. So we used video cameras that recorded the behavior of the children and educators after an alarm in order to allow an assessment and measurement of the pre-movement time and also of the walking speed. Furthermore, the total evacuation time was measured. So evacuation was completed, was considered completed once all occupants had reached the appropriate assembly area outside the building. So following, I can just present, because of time, I can just present some really general results that could be observed. For more detailed description, please take a look into the conference paper. So concerning the behavioral patterns after an alarm, it could be observed that a short moment after the educators themselves have interpreted the alarm, they assembled the children in order to initiate an in-a-body evacuation. And the children, also depending on their distance to the educators, reacted differently. So the individual pre-movement time as well as their individual mobility until reaching group has an influence on the group-related pre-movement time. And also it could be observed that the collective movement did not begin until all children have assembled. Well, concerning the escape movement, the walking speed of the pedestrian flow was determined by the slowest person, which could actually be a child or an educator. And the flow was formed by an educator at the head of the group guiding the children and a second educator driving the children at the end of the group. So for data collection, we designated the nursery schools with the capital letters A to D. And as I just said, there are differences between the nursery schools. So for example, in nursery school A, we conducted 2 exercises. For C, compared or from the point of view of fire safety, this nursery school is equipped best since it has a modern fire alarm system, and evacuation exercises are conducted every year. Special about nursery school D, for example, was that this nursery school had no adequate alarm system at all. So this figure shows the measured group-related pre-movement times. And we divided the group-related pre-movement time into 2 periods. So first, from the alarm till the educator gave instructions to the children. And the second period takes into account the time to assembling and preparing the children for the upcoming evacuation. And as you can see, the composition of the group-related pre-movement time does differ across the groups, but also across the nursery schools. And also, here shown by the orange points, the total evacuation time is given. And as you can see, the duration between the highest pre-movement time and the total evacuation time is pretty similar in every case, which indicates that there's not much potential regarding the movement time, but regarding the pre-movement time. So a short summary of the exercise results. If both exercises in nursery school A were regarded separately, 426 people were involved in the exercises, and the escape movement was always structured and the groups stayed together the entire time. The alarm systems were criticized by the heads of each nursery school. So in nursery school A, it was clearly too quiet. In nursery school B, for example, it was irritating and partly too loud. In C, even if they had a modern alarm system, it was still a little bit too quiet. And in D, it was criticized that there was no alarm system at all. So for the nursery schools A to C, it could be observed that the educators had difficulties in interpreting the alarm signal. And in principle, after an alarm, whatever it was an alarm tune or verbal communication, a similar behavior could be observed. So the children waited for instruction and therefore they behaved dependently but not irrationally. Also, it could be observed that some younger children were not able to respond promptly or adequately to instruction and may need to be collected by an adult and then carried or held by the hand. Also, the results had shown that in untrained nursery schools, there is a clear potential for optimization regarding the pre-movement time. So in the second part of my presentation, I want to talk now about the challenges when implementing our collected data in the evacuation model FDS-EVAC. And first, it was tried to represent the evacuation organization by creating herding agents which are actually characterized by the fact that they look around to see what other agents are doing. And when these move to an exit, the herding agent tries to follow them. If there's no known exit or agent in the vicinity of the herding agent, it will stay in its initial location until the end of the pre-movement time. And if the nearest neighbor of the herding agent starts the escape movement, then the herding agent will follow the neighbor regardless of his own pre-movement time. So certainly, this described behavior of a herding agent could be applied to children as well. But the high sense of responsibility of the educators towards the children cannot be presented adequately by creating herding agents, because an independent escape of the children or a selfish behavior of the educators can generally be excluded. And therefore, another approach was chosen, and here reference is made to the open source project Evac.F90. And actually there is an approach to a group model which is implemented in the current version of FDS. And as far as I know, this function has been implemented several years ago. However, the function is not documented in the FDS Evac manual, and also the functionality of the group model is questionable. But by using this function when creating agent groups, was tried to represent the evacuation organization in nursery schools. So there are very few systematic studies on the evacuation behavior of children, and here, with our experimentally obtained data, we tried to modify the default agent type child in FDS Evac, and to facilitate classification, some measurements from comparable studies were used. So, for example, concerning the walking speed, Larousse, Dortier, and Dederichs measured the walking speed in nursery schools, and they divided the children into two age groups, and here their lower and upper limit for the walking speed is given. They also give average walking speed, which is 0.6 meters per second for the age group 0 to 2, and 0.84 meters per second for the age group 3 to 6. However, it should be added that these measurements were obtained at a low density and therefore represent the free walking speed of the children. Our research has shown that one should not focus the individual walking speed, but the walking speed of the pedestrian flow. And therefore, we modified our lower and upper limit for our age groups. Also, the space requirements of children are lower compared to those of adults. And the smaller size of the children is a significant advantage at bottlenecks, for example. And therefore, we also modified these body dimensions. And here we took the parts 3 and 4 of the Dortmund longitudinal growth study. And as you can see, just for example, considering the children aged from 3 to 6, these are measurements from the growth study. The shoulder height was measured, which is actually 2 times RD, and compared to the default dimensions of the agent type child, you can see that the body dimensions really nearly have to be halved. So findings about the children's pre-movement times in preschool education institutions were determined by Kolesnikov, and here are given for maximum values, which are depending on the weather conditions. So because of hypothermia, the children were dressed adequately in the winter. In spring and autumn, this was not necessary to the same extent, and in summer it was not necessary at all. So therefore, the lowest pre-movement times and also the lowest scattering were achieved in summer. And As a provision, the children were wrapped into blankets in order to reduce the pre-movement times during the cold seasons. During our exercises, we always take the weather conditions into account in order to be able to avoid having the children dressed up because of cold temperatures or rain. And our maximum pre-movement time is 147 seconds, and the average of all measured pre-movement times, group-related pre-movement times, is exactly 1 minute, which is in the range between the summer and the children wrapped into blankets pre-movement times. So our measured group-related pre-movement times were converted into a histogram, and the empirical distribution was approximated with a log normal distribution with the parameters mu and sigma, and these serve as input parameters to the simulation. And now I want to show you a simulated exercise here in Nursery School B. And as you see, it starts with an alarm and, oops, didn't work. It starts with an alarm, and immediately the agents gather into a circle, and the circle rotates as long as the highest pre-movement time of one agent in this group is reached, and then the collective movement towards the assembly area begins. So this table summarizes the evacuation times of the exercises and the simulations. And as you can see, in 4 out of 5 cases, the minimum value of the simulated evacuation time is higher than the exercise evacuation time. And in this one case, the exercise evacuation time is only 1 second longer. Well, due to the input parameters, it is traceable because the defined pre-movement time in the simulation strongly determines the required evacuation time. And the problem here is that we measured group-related data, which is actually an FDS used for individual agents. So as the number of children within a created group in FDS evac increases, so does the likelihood that the child will be assigned a high pre-movement time or low walking speed. And in these worst case input parameters are decisive in several groups. So once more, for clarification, our data is group related, but in combination with a chosen group model, it can only be applied to individual agents, and this in turn leads to an overestimation of the evacuation time. So to point out some conclusions concerning the exercises, the familiarity of the educators with the alarm is of paramount importance and depends on the type of the alarm system. As you could see, the pre-movement time does differ across the groups and also across the nursery schools, and following key statements do apply. So the evacuation of the group is controlled by the educators, and they have a decisive influence on the duration of the pre-movement time. They direct all actions to be performed during the pre-movement time and must provide a variety of assistance as holding hands or carrying children. And also, they determine the walking speed of the pedestrian flow. Concerning the simulation, well, with FDS AVAC, the observed evacuation organization could be only implemented very simplified. Although the physical parameters as the walking speed or the body dimensions can be implemented very good, the representation of the organizational process of the nursery school is not realistic. So therefore, it is difficult to counternounce an evacuation simulation in order to compensate a structural or technical measure in schools, in nursery schools. And well, this is still because there is a lack of knowledge about the escape behavior of the children. So finally, to point out some potential for optimization regarding fire safety, our research has shown that more attention and investigation should be drawn to the organizational fire protection measures and the alarm systems in nursery schools. Also, statutory evacuation exercises, an appropriate alarm system can increase the level of safety in every nursery schools where no voluntary evacuation exercises are performed. And the exercises offer a successive optimization of the pre-movement time and therefore also of the total evacuation time. And concerning or talk about the use of evacuation simulations in nursery schools, well, they could be used for training purposes. So an evacuation simulation in nursery school can be compared with a real exercise, and the advantages of a simulated and optimized evacuation could be demonstrated to the educators in order to show them what evacuation times are possible to reach. So, yeah, thank you for your attention.
Thank you, Jan. Do we have any questions? It's a quiet group this afternoon. There we go.
So you mentioned several times that a standard alarm signal can cause anxiety in children. Was any research put in place into a more appropriate alarm system so that staff are aware of what's going on and the children aren't as scared? Did you look into that, or is that to be done?
I just recognized it that there is a difference because we had different tunes of the alarms, and the tune and the volume of the alarm system did have an impact on the children, but I cannot write it down because there's not much data for not enough data for that.
Any other questions? I know my little daughter hated loud alarms at school. She dreaded drill days.
I have a question. What do you think would the scattering be if you would have made this exercise maybe 10 times in a row with 2 or 3 days in between, once before they eat, one when they sleep, one in the late afternoon? Do you think the scattering of this exercise data would be much higher than your scattering, what you normally could get out of the simulation, only because of the pre-movement times are that much different in between?
Well, I think for the single nursery school, the scattering would be bigger, yeah. But for global overview, I think the scattering wouldn't be that much greater because on purpose we chose different nursery schools. And well, you said how would the pre-movement time change if we have, like, for example, 10 evacuation exercises. I would say it's not possible because they are children, and I have and it's hard to repeat evacuation time and evacuation exercise that often. So I think you cannot solve that.
And your personal thinking about this, what do you think by heart, just without
by heart?
Yes.
Well, by heart, I would think.
Or your brain, that's okay.
Yeah. By heart, just like I said, I think for the single nursery school, yeah, there will be a scattering, which is depending if kids are sleeping or not. It will scatter much. The scattering will be much greater. But for the global view, I don't think the scattering will scatter a lot.
And you didn't plan each of these different schools at the same time of day, did you?
No.
So you already have some variation built in.
Yeah, and in 3 out of these 4 cases, the exercises were completely unannounced. So the educators had no idea, and also the children had no idea. And in this one case, when it was half announced, the educators as well as the parents were informed about the upcoming evacuation, but with the request not to inform the children. So, yeah.
All right. Well, thank you very much. Any other questions? No. Thanks again, Jan.